Hello, and welcome to DI How to Live webinar. My name is Shawnee, and I'm the training evangelist for Dealer Inspire. And what I do is bring you all kinds of information and guest speakers to speak on that information about the amazing work that we're doing here at Dealer Inspire. So today we have a very special guest with us. He is the Senior VP of Engineering. I don't know what that means, but all I know is that there's got to be a lot of initials after his name. So he's going to talk to us all about your sites, how we keep it from crashing and burning, how we keep them running at peak performance, all about keeping site speed and managing loads and high availability, and all these great things that we as visitors we don't know about, but we just know that we want our website to go and go fast. So that is Jack Peterson. Thank you so much for joining me today.
Thanks for having me, Shawnee. I'm delighted to share some of the driving principles that the Dealer Inspire platform is built on. When it comes to information technology, there are plenty of terms out there, and many of them are rather unintuitive. My goal today is to act as your translator for a few IT concepts that are relevant to the web hosting space. So, without further ado, I'll go into the topics that are in scope for this discussion. So, first of all, we'll be talking about what does high availability mean, and how does DI achieve it? Then we'll talk about how does DI handle peak traffic or variable load. So this is all about, let's say your dealership is running a massive advertising campaign. You have newspaper advertisements, various Google ads running, maybe even a TV ad running, and all of a sudden you are driving much higher traffic than normal to your site. This is all about making sure that the services can actually handle the number of requests that are coming in from visitors. And then finally, we'll be talking about how to keep sites performing fast, and specifically, how does DI do that? And then finally, we'll wrap up with an open question and answer section. Please feel free to submit any questions as you think of them, and at the end of each section, I'll do my best to answer them. All right, so first of all, let's work out a definition for high availability. So high availability is the percentage of time that a system is operational over a set amount of time. That might be a little bit ambiguous, so let's break it down into other terms. Let's say you go to your favorite fast food restaurant and they're actually closed on Sundays or something like that. Well, their availability is 6 days a week. So we need to make sure we come up with a consistent way of measuring this. So we'll just work in hours because that's a fairly standard way of doing it. So let's figure out how many hours there are in the year. So 24 hours a year, or 24 hours a day times 365 days a year gives us 8,760 hours of total time, or the set amount of time. And if we want our site to be 99% available, sounds pretty good, it'd be up 8,672 hours out of that 8,760. So sounds pretty good, but actually that's 87 hours of downtime. Not so good. So getting high availability is really about seeking more nines, so taking it from 99% to 99.9%. And actually, as we go into this further, you'll learn why this actually entails a more complex architecture than what would be rather intuitive. Making matters more complicated is that IT folks actually divide that high availability, or the percentage of uptime, into two different categories. Planned outages, so that would be something like a change request or otherwise, and unplanned outages. But from my perspective and the Dealer Inspire perspective, we focus on total availability. Whether it's a planned outage or a unplanned outage, we care about uptime. So what we need to do next is figure out where things break. And this was actually quite a bit of a lesson learned for us as we started out at Dealer Inspire. Originally, we would discover, there's a lot of traffic coming to one server, and maybe the web service would break. So Apache, the HTTP service, would go down. Or maybe people would be browsing lots of vehicle results or running different searches. That would drive a lot of load to the database service, and that would crash. Occasionally, software updates at the operating system would break things too. And once in a while, individual components on the server would fail. So that could be something like a hard drive, or memory gets corrupted, or since we are now in a modern cloud infrastructure, the actual hypervisor or the physical server that a virtualized server sits on might have a problem as well. Then with previous hosting providers, we'd actually experience more widespread issues. Whole data centers would go down. they would lose their internet connection. Maybe a construction crew would cut the internet line accidentally, and that's outside of the actual data center, but that results in the site being unavailable. And same things happen too within the data center. Cross connects, the components that connect a number of servers to the main internet drain within a data center, those, due to human error or a failed component, those might go down. So Dealer Inspire really took a approach, a heavy learning approach to figuring out, okay, how can we maximize uptime, or how can we increase the availability and truly get to a highly available state?
Hey, Jack.
Well, when we first, yes?
My apologies. Can I break in and ask a question real quick?
Oh, absolutely.
So when we're talking about, let's say, high usage, okay, I just want to get an idea in terms of scope here. So are we talking about, maybe a company our size and everybody's got like, 2 or 3 tabs open, and that could cause downtime? Are we talking about like 1,000 people on the same site with 1,000 tabs of the same site open kind of thing? Like, we're, it's scope wise,
Yeah,
what would need to happen?
that's actually a really good question. And the answer to that, which I hate to give it to you in kind of a vague way, is it depends.
Okay.
So a homepage that's very simple, without any complex database queries, you could have thousands of visitors hitting that, and a single web server could probably handle that. To give a little bit of perspective, Facebook, when they first started out, their web servers, if I recall, is only handling around 20 to 40 transactions a second, which is like 20 visitors hitting a server at any given point in time, regardless of where they're at. And as we'll go into a little bit later, this kind of goes into the topic of scalability, which is
Hmm.
all about handling the increasing the number of simultaneous visitors you can handle on there. So to kind of give a little bit of an answer there is it depends on the complexity of the query and how computationally expensive a given request is. And that can just vary just depending on what type of content is on the site. If you have lots of inclusions, maybe vehicle counts, those type of things, that drives up the complexity of the site and actually correspondingly decreases the amount of total capacity a server could have in terms of being able to serve simultaneous visitors.
Okay. All right, great. Thank you.
Yeah, absolutely. And then feel free to pop in with anything else you got there too.
Okay.
Um, so give a little bit of history here with Dealer Inspire. So we first started out, we had individual customers on a LAMP stack. Now, LAMP stands for Linux, which is an operating system, Apache, which acts as the web service. That takes like a request to go to the home page, and it translates that, passes it over to PHP, which is the scripting language that the sites run on, and MySQL, which is the database. So LAMP, Linux, Apache, MySQL, and PHP. We would typically divide one site or one group of sites. So let's say you had Bob Jones dealerships, and they have Hondas, Toyotas, and a couple of other individual rooftops that they have. We would group those together and then size the server appropriately. Each site was isolated, and this deployment model was very repeatable. New customer led to a new server. The problem, though, was that as we began scaling out customers, that a given server, and it would vary as to what type of failure it would experience, would become more and more frequent. Not on an individual basis, those would happen fairly rarely, but for some reason, almost every day, a server would fail. And although as an aggregate, we had a high percentage of availability, individual sites would experience long outages as we tried to triage individual problems. This was absolutely unacceptable. So we had to start diving into figuring out, okay, we need to change things because this is not good as a customer experience. So let's kind of go down that path, figuring out what we need to do. Well, the first step is understanding what's going down and where. It's no good if you have a customer calling in saying, hey, my site's down, and you're not aware of it. We need to be aware first, and that way we can proactively resolve problems as quick as possible before our customers even notice there's an issue. So we set up an external service, Pingdom, and they'll hit the website from multiple locations, maybe somewhere in Washington, maybe somewhere in New York, maybe even somewhere in Europe. And as a whole, that will let us know if there are problems with the internet as a whole, with possibly a localized condition. Let's say New York, for example, Hurricane Katrina, that would take out links within the New York area, but the site would still actually be available for everyone else. So then we would know, well, the issue is not specifically with our systems, but it's actually an internet level problem. Then we go down one extra level here. We need monitoring at the cluster or the server level. Well, we recently made a transition to Amazon Web Services and implemented a highly available clustered topology for the web services. It's a lot of big words there, but clustering, and we'll get into this a little bit more later, but this is all about having multiple sets of servers. So what we did is we have monitoring on the systems, and it'll let us know if we have a low number of web servers or lower than expected, and that lets us know, okay, perhaps we need to adjust what our scaling policies are. Then at an individual server level or a process level, we have Monit running, and this will do things like watch Apache, and if Apache as a service goes down, we need to automatically restore that, and occasionally it does go down, and so we need to have something that gives the system a little kick, automatically restart it. So this brings up the next topic of, well, seeking more nines is actually kind of complex. At a glance, if we were taking a look at our system, on the right we kind of have a chart here. We have a server, it has a database, which is MySQL, it has a bunch of files on there, so that's like your WordPress files, uploads, images, all that type of stuff, and it's running Apache. So you go, okay, let's just create a mirror of it and have a failover system. Sounds pretty good. If server A has a problem, we just need to flip traffic from A to B. But now we need to mirror the database, and it needs to be live and really close to real time. And we need to do the same thing with files. For example, if someone uploads a new image and they go somewhere else, if the image isn't available when we flip over to server B, we now have a new problem. And when we fail back and mirror everything the other way, we now have a permanent loss on a file. So that's not really a good solution. It's not viable either at scale. And one final problem with this is that the cost is always twice whatever you need at any given point in time. Server B is just sitting there idle, waiting for you to fail over. It's not particularly fun to manage. So we go, okay, we need to do a research-driven effort to make sure that we reduce the impact of breakage. So what do? Should we add more web servers? Well, yeah, that's a good thing. Add database server failover? Yeah, that's awesome too. Well, we got this nasty problem with files, and having multiple servers handling traffic suddenly means we have two different brains, if you will. Server A might have image A, B, and C, and server B might have image D, E, and F. And we need a way to consistently manage those different image sets. And then furthermore, we experienced whole data center outages. They're extremely frustrating. So even having two servers next to each other wouldn't solve that. The site would still go down if the internet link got cut. So with that, I'm going to open it up for any questions we have on the high availability topic before we go into how we solve those problems. Shawnee, do you have any open questions at the moment?
No, it sounds like everything is, you explained everything pretty clearly. The problem is like with every solution, there always needs to be a counter solution. And I wonder if that has something to do. In fact, you can let me know. Are we about to go into redundancy? Does redundancy play a fact in any of this?
Yeah, absolutely. We're going to go into redundancy, but I'm going to bring up one more problem.
Okay.
And I'm actually going to transition back to this one slide here with this server A and server B. As the number of requests increase on server A, it was sized when we first built it for a certain amount of traffic. And as peak load hits, server A might fail, and then we'd transition traffic over to server B, but it's sized the same, so it too would go down. So this brings up our next topic, which is all about scale. So scalability, I want to give a clear term. So scale does not mean performance. A lot of people talk about scalability and they think, oh, that means it's going to perform well. Well, it's not. And let me give an analogy for the taxi service. Taxis are a highly scalable service, but they don't necessarily perform well. Scalability in this context means if you arrive at the airport and you're looking for a taxi, another one will always be available for you. It's still going to be subject to the same traffic laws, assuming you have a law-abiding taxi driver, but it's not going, taxi A won't necessarily be any better than taxi B. They'll still get you from point A to point B, but it won't run any faster than another one. So scalability is all about making sure you can service those requests as the number of requests increase. So as more people come to the airport, more taxis show up. Similarly, we've got the same type of concept with web servers. So as more requests come in, we need to add more servers. So the HA model we talked about, or high availability, it doesn't account for that. So we need an architecture that can solve this problem. So next I'm going to pull up a logical architecture diagram. It doesn't necessarily indicate all the technical nuances, but it's a good high-level picture of it. So we mentioned we need high availability, and the solution we came up with was we need to separate individual components at their own level. So for example, starting at the bottom, we have RDS, which is Amazon's relational database service. We've got individual databases, and at that layer, it's a highly available system. It's got failover, automatic, and we also have slave servers to handle scale requirements for read requests coming in. So as more people request the home page or vehicles, load increases on those slave servers, and we can add more as needed. Furthermore, if one component at that level fails, it's not disastrous. Each layer has its own redundancies. Then we'll move up to the next level, cluster FS. Sounds complicated, but it's really a clustered file system. Now, clustered file systems are kind of interesting. They allow you to scale out your storage so you don't have all the load sitting on one hard drive, but rather it's one hard drive across 3 servers. And in a sense, what you do is you mirror them. So we have 3 copies of data at any given point in time. And the way the system works is that every write requires an acknowledgement. And what's also interesting here, you'll notice that, well, that's the one thing that's kind of different. Zone B has 1 less cluster server than Zone A. That's kind of odd. Well, this is a technical design that we have here, but it allows for voting in the system. By having an odd number of servers, they can actually decide which 2 have the correct set of files. And by voting, you can ensure you have consistency. And then finally, at the web server level, that's the very top, these scale out based on traffic. So the idea here is that as the number of requests come in on the web servers, we increase the amount of them to handle more folks coming there. And furthermore, if an individual zone goes down, so if Zone B goes down in its entirety, we just add more servers into Zone A, and that handles the load. So we don't have that problem of twice the capacity that's not being used. We actually use just the right amount of capacity based on the number of requests. And so this is the high availability architecture that's also highly scalable with respect to the Dealer Inspire platform. So individual failures at each component won't drive an outage. So if a file system goes down or a web server goes down or even the database goes down, no problem, it'll fail over. And as a whole, the system remains up.
Okay, so let me see if I got this, and I'm going to give the toddler version of that. See
Absolutely.
If we understand it. So, so the way that I'm kind of picturing this is almost like one of those those fountains, right? Where you have some water coming into a bowl, and then it's like a champagne fountain, and then you have more people coming in, so more champagne coming in, so then the champagne overflows into the other ones. However, in this situation, there's also the reverse. You can also reverse that. So basically, the architecture expands for traffic and then retracts for less traffic. So that's where the scalability comes in. Is that kind of like a balloon?
Yeah, exactly. It is. It is a lot like a balloon. So you fill it with more air. Although I like the champagne analogy.
Yeah, me too. So, now I want to get some.
That's right. So, but we'll stick with the balloon one. Yeah. So the more air you fill with it would kind of be like the number of requests. So you need to make sure your balloon grows to the appropriate size to hold that amount of air. Same kind of concept there, except with servers and all that.
All right. Well, you can count on me to make anything really down to its barest essence.
I love it. All right. So that sounds good. We can handle lots of requests and all that jazz, but it might not be fast. In fact, dynamic websites, and I'll break this term out, are slow. They're horribly slow. It's so slow it's intolerable. Nobody likes a slow site. And doing things on WordPress is actually kind of painful in that way. WordPress is great. It's very, you can put as many plugins as you want and all that. But the challenge it brings is that because it's so dynamic in that nature, meaning you have all that flexibility, it also can mean that there are sometimes performance penalties, and it's a little bit difficult to diagnose them. For example, you might have a forms engine on your site, or you have inventory on your site, and all these things as a whole, they have to perform database queries. They have to ask, okay, I need all the vehicles, I need all the information about forms, I need to generate a navigation menu, and for each item on the navigation menu, I need to know how many vehicles there are. And all of that translates into a large number of and complex queries to the database. And that all adds up to time. So what we need to be able to do is achieve both performance and scalability, because that's what translates into higher sales and a better end user experience. So there's a famous old quote, which is that there are two hard things in computer science: cache invalidation and naming things. And that was by Phil Carlton. And ironically, naming things comes down to how you just write things out, and that can lead to lots of arguments among developers. But let's talk about caching. So caching is about saving a copy of the output. The idea here is that once you have a copy of the output, you no longer have to make a query. So the most efficient query is the query that is never made. So let's talk a little bit about the cache strategy at Dealer Inspire. So we mentioned earlier that we have a network or a clustered file system, and that allows us to scale out web servers. But it comes with a penalty, and that's horrible write performance. And that's because the whole system requires an acknowledgement across the board. So anytime you upload a new file or anytime you rebuild sites, every file has to be acknowledged and agreed upon by the storage system before it can say, yes, I know the right file to serve. So we need to actually put caching local to each web server, which brings about an interesting problem. The problem is that now you have differences among these different web servers. So you have someone hit web server A, they say, hey, I want the home page. That's great. They get it. Web server A stores a copy of the home page on itself, and then any future request coming to it will get served out, and it'll never have to load any of the database side of things. It's a sub 200 millisecond response, very, very fast, versus the typical WordPress bootstrap, which is around 5 to 10 times slower. But the challenge here is that web server B, C, and D, or however many we have at a given point in time, they haven't actually gotten a copy of the cache. So for however many web servers are active, we actually need visitors to visit these four different sites or four different servers in order to get the system fully cached. So it's a known issue that we have, and so far it's worked pretty well. But what we're currently doing is we're researching a strategy to go about propagating that cache, or to distribute the cache from web server A across the board for every active web server. So it's a unique challenge within computer science and specifically at Dealer Inspire, but I'm excited about what we're developing. So pretty soon we'll have something there. With that, I'll just provide a brief recap of what we've discussed. First of all, what we talked about was the architecture and what it looks like and how it's highly available at Dealer Inspire. Secondly, how the system scales. So how it grows and shrinks, much like the balloon, to the amount of requests that are coming in and how we handle peak load. So as more requests come in and we measure that, we increase the number of servers to make sure that we are always able to deliver a request to the next visitor. And finally, we talked about performance. And that's all about caching. So we create object caches and full page caches, and those reduce the amount of queries to the system, but also obviate loading the WordPress platform as a whole, which allows us to deliver lightning fast sites. With that, I'm going to open up to an open Q&A session.
Okay. This is great information. It's one of those things where I hear on the, I don't want to say lower side, but more on the topical side, we talk a lot about caching, especially on the front end because of the kind of innovations that we can do. So one of the questions I want to ask you is, what are what are some things that either our dealer inspired clients can do, or the things that we do on our side or on our end to kind of help website health, to kind of keep the cache open, keep the site going. For instance, we have Personalizer. Personalizer uses a plugin, amazing, absolutely amazing plugin and capability with geofencing and all that great stuff. But with geofencing, it's going on to Google Maps. It's looking at the coordinates of a place, and then it's thinking, okay, this visitor is now in here. I'm looking at this thing. I got to pull this criteria to show this image on the screen. So, is there a housekeeping list or something like that to keep sites at
Yeah,
peak performance?
that's a great question. So, as things currently stand right now with personalization, it requires, as you mentioned, a lot of different pieces of information. So, the rules that one can apply to personalize are really elaborate and really quite amazing when you look at what type of information you can achieve and how you can uniquely target to a specific visitor. The downside of it at the moment is that personalization requests do require that a page is uncached. So we can have object level caching for things, which might be the vehicle results or the menu navigation at the top, and those things win from a performance standpoint. But we don't have the full page cached for that specific user, and that's because it'd be very difficult to, I guess you could say, enumerate the possible combinations. So to know if a visitor is within a very specific geographic region and simultaneously came from Facebook or something along those lines, and that they had also searched for, say, a 2015 Honda, um, that would be a unique set of combinations that are difficult to cache for. So um, at the moment, as it stands, we don't have caching for the personalization plugin. However, I don't want to commit to anything yet, but it's in development and our developers are actively working on that, and they've come up with some pretty clever solutions to that. So
Well,
in
yeah,
the
I've,
near future, we may have a full caching solution there.
excellent. Well, yeah, I have no doubt of that. I mean, and that's one of the things that always interests me because we do quite a bit. I have not noticed or heard of any kind of complaints with sites getting bogged down with personalizers. So whatever what if there is some sort of heavy duty um, memory usage on something, we're not seeing it on the user side, we're not seeing it on the visitor side. But it is just interesting because I know with the amount of inventory, all the pieces and parts that go into a website, especially with e-commerce, automotive e-commerce site, it's one of those things you kind of take for granted that it's going to be up and it's going to be working. But there are so many minutia. There's so much minutia and so many different, computations that are happening in any millisecond that it's just mind-boggling that that you guys got a handle on this and can handle all of that because it's insane. It's insane.
It definitely poses some unique challenges, but that's what keeps it interesting.
Oh, of course, of course. And as many of our listeners know, that we are constantly innovating. Your site will never get stagnant or stale, and we're always coming up with something bigger, faster, and better. And so it's also good to know that we got engineers such as yourself making all of that be a possibility by keeping the sites going, keeping it peak performance, and making sure that our clients have their sites ready to go at a moment's notice to handle anything. So that's a comfort to me personally.
Yeah, we've got a great team of engineers, and we also have a very innovative leader who's heading this up. So it's really cool to see where Dealer Inspire started, but also to see where we're heading. So I'm looking forward to the future, as I'm sure many of our customers are too. So
Absolutely.
it's great.
Okay. Well, is there? I guess that's it. So, okay, let's say that somebody is having a little issue with their site and they feel like it's a little sluggish, maybe a little slow. So, where do we direct them to kind of help? Where do we direct them? Is there an email address or should they contact their AM support?
Yeah, so the first thing they'd typically do is they'd just go directly to the support team. The support desk is first and foremost the best way to get the technical help, I would say. And then the task would be passed out. We'd determine if, say, for example, what we often find is actually third-party inclusions are what drive down the appearance of site speed. So we'll first take a look, okay, is the server responding efficiently? If it is, then we need to really start diving into the more technical nuances and what's unique about a given site. So if they're including a third-party JavaScript or something like that, and it's causing the page to not render efficiently, then we'll research and coordinate with them as well as the third party to make sure that that's working well. And occasionally we will discover something unique on our side, and we'll work as quickly as we can to triage that, identify the problem, and push out a fix. So that's actually one of the ways that we ended up implementing the architecture that we did was through unique problems that were very specific to, say, a large inventory dealer. Those are problems that are unique to people with large inventories, but as a result of that effort, everyone won in that sense. Everyone got a much more fast, much more performant website as a result of the engineering effort. So, yeah, it's definitely, I think it's the greatest thing when customers reach out to us and let us know, hey, there's something's a little bit weird here. Can you guys look into it? Because that's a win for everyone.
Right, that's what drives progress. All right. Well, you heard it, folks. Support at dealerinspire.com. For whatever reason, definitely probably won't be for site speed, but just so you know, you always got somebody there to, hold your hand and help you out for something, and we're always there to take care of whatever you need. So, Jack, if you could go to the next slide for me, there, Jack. So,
Absolutely.
and I want to thank you very much for being a part of this webinar series with me today, being my guest host. I truly appreciate it, and your knowledge is amazing.
Well, thank you. I'm humbled to be here.
All right, well, thanks. All right, folks. So our next week, we're going to talk about personalizer. You're going to show you. I'm going to show you the top 10 ways to become a personalizer ninja. What? Who's going to do that? That's right, your very own training evangelist. I'm going to go through the ways to make personalizer run in tip-top shape. We know that it will and can after today's webinar, and I'm just going to show you the ins and outs and the pieces and parts to help you really use personalizer to its best ability and really make sure that your message gets there to your targeted demographic. So please sign up for that next week. Also, as always, if you need any training or if you have any questions, please reach out to me at dihowdoi at dealerinspire.com. And you can also check out our website, dealerinspire.com, and look for my page, hashtag dihowdoi, as there is a link. So thank you so much for listening. And once again, I'm Shawnee, the trainer of technologies for innovative dealers such as yourself, and I will see you all next week.